Welcome back for this session. In the last session, we have seen the generic circuit where we can get different configurations, and we replaced the MOSFET with equivalent circuit, and then we calculated V01 with respect to VI, V02 divided by VI. Okay. I hope this is done. If this is done, now let's see one by one. Okay. Write down common source amplifier. Number one, common source amplifier. Right? Now, listen, don't write. And I want to tell one more point which I did not tell before. See, in the case of BJT, we used to consider VSRS, the practical voltage source. But here I am always considering VI. Reason, even you consider VSRS doesn't matter because the current entering into gate is 0. If current entering into gate is 0, what about the drop across that internal resistance? RS of practical voltage source 0. Then Vs is equal to Vi. Therefore, directly you can represent Vi. No need to represent Vs and RS. Okay? That's what. Anyway, we are trying to find the core voltage gain, right? Therefore, this is V0, RD, this is VDD, drain, source, gate. Is it common source amplifier? How? Right? Maybe whatever I explain the same way, let me explain for BJT also. For BJT, this is nothing but CE amplifier. Then what is CE amplifier? Just AC circuits, okay? This is input voltage Vi and V0, this is RC, VCC, right? Collector, emitter, base. This is common emitter. How? Applying input voltage at base with respect to ground, emitter is at ground. Taking output voltage at collector with respect to ground, emitter is at ground. For both input and output, emitter is common, therefore common emitter amplifier. Applying input voltage at gate with respect to ground, source is at ground. Taking output voltage at drain with respect to ground, source is at ground. For both input and output, source is common. Common source amplifier. Right? Now, tell me what is voltage gain. Therefore, this is nothing but AV. Voltage gain we are trying to calculate. V0 divided by VI. Remember, out of 4 AC parameters, we need to calculate only 2 AC parameters. Because input impedance is infinity, current gain is undefined, voltage gain we need to define, output impedance we need to define. Okay. First of all, let me complete voltage gain. Then we will see in a way, in a different phase, what is output impedance. Okay. Let's see. Therefore, what is V0 by VI? We already calculated this. If you see the generic circuit what I gave before, that is nothing but V01 divided by Vi when RS is equal to 0. Therefore, when you short RS is equal to 0, define your output here, that is V01 divided by Vi when RS is equal to 0, which we already calculated, right? Then substitute what you get. What is V01 by Vi? That is nothing but minus mu into RD divided by capital RD plus small RD plus 1 plus mu into RS. But when RS is 0, substitute RS is 0, then what you get? Then we get AV is equal to minus mu into RD divided by capital RD plus small RD. Because RS is 0, then we know that what is mu? Mu is equal to GM into small RD. I told that this is amplification factor. You substitute, therefore AV is equal to minus GM into RD divided by capital RD plus small RD. If you observe clearly, it is like what? GM into RD into RD, R1 R2 divided by R1 plus R2, this combination, right? Therefore, if I write it like this, minus GM into capital RD into small RD divided by capital RD plus small rd. It is like R1 R2 by R1 plus R2. Therefore, this is nothing but minus GM into, people call this as RD dash. This is what is the voltage gain. Where, what is RD dash? RD dash is nothing but capital RD in parallel to small rd. Right? Therefore, what is your voltage gain? Minus, I'll explain what is the meaning of minus. Minus into GM into effective resistance. What is that effective resistance? The internal resistance, which is small rd, into the external load what you have, that rd in parallel to small rd, is nothing but your voltage gain. Okay, that is what is fine. Therefore, effective resistance. Therefore, what is this? This is nothing but minus GM into R effective resistance at output. Therefore, effective output resistance. Effective output resistance. Okay, that is what. This is what is minus GM into R effective output resistance. That is fine. Now, coming back to your BJT. Coming back to BJT, we had solved already, right? This is common emitter amplifier. We got what is voltage gain? We got voltage gain AV is equal to just repetition and then correlation. That is easy to understand and easy to remember. Therefore, what is that? We got AI into RL divided by RI. We know AI minus HFE divided by 1 plus HOE into RL, and RI we know HIE plus AI into HRE into RL. That is what is exact model. Now let's go for simplified model. Let us say if I neglect base width modulation, therefore if base width modulation is 0, base width modulation is 0, right? Then what is the voltage gain? Voltage gain is called minus HFE into RL divided by HIE. What is HFE divided by HIE? That is GM from hybrid pi model, right? From hybrid pi model, minus GM into the load RL. This is what is our voltage gain, right? Therefore, minus GM into the load what you have. Here, what is the load? RC. Maybe if you connect external load, RC in parallel to the real load. What may be GM into effective resistance, which is what is present at the output, right? Therefore, similarly, if you neglect channel length modulation, then what will be small rd? Small rd will be 0. Therefore, if you ask me, I don't have space here, right? Or I can say, if channel length modulation, that is 0, then what does it mean? That is nothing but lambda is equal to 0. What does it mean? Small rd is infinity. Then what is the voltage gain? Then voltage gain is equal to minus GM into RD. Therefore, minus GM into RD. Similarly, here what is that? RC, which is nothing but what? What is the load here? Minus GM into RC. Both are same. If you go for ideal model means if you neglect channel length modulation, what is voltage gain? Minus GM into load. If you neglect base width modulation, what is voltage gain? Minus GM into load. Both are same, but only the difference is what is GM. What is GM of BJT? What is GM of MOSFET? Here the GM for the BJT, here GM for the MOSFET. Maybe if you take JFET amplifier, GM of JFET amplifier. Maybe in future if you get new device, GM of that device. That is what you need to replace. But circuit wise, the formula whatever we are getting, those are all not changing, right? In future if you get multiple devices, ultimately GM into load. Okay, fine. If you represent like voltage controlled current source, you can take it. Therefore, first configuration is over. Common source amplifier, and no need to remember as extra formula. AV is equal to minus GM into effective load or RD dash. If you neglect channel length modulation, that is simply minus GM into RD. But remember the formula which is in bracket. The last one is nothing but derived formula. Okay, this is original formula. That is what is, if you compare, if you want to compare with BJT, that is nothing but the one which I kept in the bracket. Therefore, this is what is exact model, simplified model. Okay. First configuration is over related to voltage gain. Okay. One more minute, after that we will see the next configuration, CS with RF amplifier. Here what is we know, what is GM? We already calculated, right? GM is IC by VT. Similarly, what is GM here? We need to calculate. That part I will discuss later. After completing AC analysis, then I will come to what is GM. Okay. After this, over, write down observation. 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 What is the observation? Your voltage gain is not stable. That is what we have seen here also, right? Why voltage gain? It is depending on H parameters, right? Or it is depending on GM, and GM is depending on IC by VT, where IC is equal to beta into IB plus 1 plus beta into IC naught divided by VT. Therefore again it is depending on temperature. GM is depending on temperature. Voltage gain is depending on temperature. Or voltage gain is depending on H parameters. H parameters are depending on temperature, time, replacement. Therefore your voltage gain is not stable. Your voltage gain is not stable. Similarly here, when I will explain the GM, right? The GM is also not stable. Means GM is also function of temperature. When I derive, you will get it. GM will be mu n Cox double by L into Vgs minus Vt. Therefore, it is depending on threshold voltage, mu n. Therefore, those are all depending on temperature. Therefore, your GM is also changing with respect to temperature. Therefore, I can say there is a variation in the voltage gain with respect to temperature. Therefore, you can say both the voltage gains, that is observation, not stable. Therefore, write down observation. What is observation? Voltage gain AB is equal to minus GM into RD dash. Just below that is not equal to stable. Voltage gain is not stable because GM is function of temperature. Because GM is function of temperature. Because GM is function of temperature. GM is function of temperature. Okay. I think self-explanation. Why are we getting minus sign here? Now, little bit qualitative analysis I can explain. Now, let us say the signal whatever you want to amplify, let us say I am applying the signal what I want to amplify, right? And this is what is the current, right? This is what is your ID, the current which is entering into drain. This is what about your ID, right? Now, maybe if I add DC plus AC, let us say VDD is equal to 10 volt. Then this is 0 volt. Okay. Now, this is 10 volt. This is 0 volt. Therefore, in between 10 to 0, let us say this is what is 5 volt. Maximum you can get is 10 volts. Minimum you can get is, let us say, 0 volt. Right? The DC part or DC biasing part I didn't show here because we are speaking about only AC analysis. Okay? But finally I will give you complete circuit, something like your BJT. Now here our aim is to calculate AC parameters, not the DC parameters. Now the signal whatever you are increasing, therefore the small signal whatever you want to amplify, when input is increasing by a small quantity, now there is no input current. In the case of BJT we have input current, right? Now the signal whatever you want to amplify, that when you apply the small signal, when input is increasing, your ID will increase because this is voltage control current source. ID is equal to GM into VGS or VI. Therefore, if you have more GM, simple, if you have more GM, the small input voltage will be converted into large output current. What is transconductance? Converting the input voltage to output current. If you have large GM, the small input voltage, whatever you are applying at the input, you will get large output current at the output. That is what we need. When you pass that large output through a resistor, you will get large voltage. Right? Therefore, indirectly, the input voltage is converting into current. That current we are converting into voltage. Therefore, indirectly we are converting from input voltage to output voltage. Therefore, we are getting voltage gain. Right? Therefore, let's see. Whatever input voltage you are applying, the small voltage is converted into large ID. That is what you are passing through RD. You are getting large drop across RD, but I am not taking output voltage across RD. We are taking output voltage across drain to source voltage. Because KVL, this voltage is equal to this voltage plus this voltage, right? Let us say 5 volt, 5 volt. Now if you have more drop here proportional to the input voltage, then less drop here. Less drop in the sense negative drop. Therefore, but you will have more negative drop. But if you see output peak to peak divided by input peak to peak, you will get voltage gain. Now, the meaning of minus is nothing but when input is increasing, your output is decreasing. That is what I already explained in the case of BJT, right? But in the case of BJT, whatever signal you are applying, let us say this is the signal whatever you want to amplify, but you are getting base current. That base current is giving collector current. Earlier, in the case of BJT, IC is not directly coming from VI. It is coming from IB, IB is coming from VI, right? Now, whatever output voltage, exactly same. This is what is 10 volts and this is 0 volt. Now, let us say before applying your AC signal, out of 10, 5 volt here, 5 volt here, let us say this is what is having 5 volt, maximum 10 volt, minimum 0 volt. Therefore, now let's see, input is increasing by small quantity, base current is increasing by small quantity, collector current is increasing by large quantity because IC is equal to beta into IB. Therefore, your output current is amplified by your input current. Therefore, with beta, then your IC is large value. The large current when you are passing through a large value of resistor, you will get large drop more than 5. Then this voltage will be less than 5 by a large value in negative direction. Then you are getting a swing. This is what I explained already before. Exactly the same way we are getting here. But only the difference between MOSFET to BJT is input voltage is converted into input current is converted into output current is converted into output voltage. Therefore, indirectly input voltage to output voltage. Similarly, input voltage to directly output current because there is no input current. That output current to output voltage, therefore output voltage to input voltage. That is what is defining voltage gain. That is what we got minus GM into effective load, and here AV is equal to AI into RL divided by RI, or GM into effective load, minus GM into effective load. The minus is nothing but inversion. When input is increasing, output will decrease. When input is decreasing, output will increase. That is what is your inversion. Okay. I hope this is clear. Right? This is what is qualitative part. The quantitative part we already did it, but the quantitative part is not explaining what's happening. For that we need to add qualitative analysis on top of quantitative analysis, then it will be clear. Remember, both are important. Both mathematical equations, both qualitative analysis or conceptual analysis, both are important to understand anything in a perfect manner. Okay. The observation, right? The observation is your voltage gain is not stable, and that is having inversion. Inversion means input is increasing, output will decrease by a large quantity. Okay. Done. Now write down second configuration. Second configuration, CS with RS amplifier. Second configuration, CS with RS amplifier. Just listen. Second configuration, CS with RS amplifier. Okay. Now, if you see the theory part is to have voltage gain stability. This is what is negative feedback resistor. Remember, that is what is providing you voltage gain stability. V naught, this is RD, VDD, RS, this is source, drain, gate. Therefore, this is what is negative feedback resistor. This is what is negative feedback resistor. Negative feedback resistor. Okay. What is this in the case of BJT? We had seen this already, right? In the case of BJT, CE with RE amplifier. Remember, source means emitter, RS, RE, like that. Okay. CS with CE with RE amplifier. Then I'm not representing VSRS. Okay, that's fine. This is collector, emitter, base, right? And we went to CE with RE amplifier to improve your AC gain stability. Okay, this is what is our negative feedback resistor, right? Therefore, tell me. Therefore, let's see whether AC gain is improved or not, right? Remember, in the case of CE with RE amplifier, the voltage gain, whatever we got, depending on H parameter, that's why it was stable, it was not stable. But when you add RE, then it got stability by having RC by RE, minus RC by RE. Let's see whatever you are getting here. Therefore, what is AV? AV is nothing but V0 divided by Vi. What is V0 divided by Vi? We already calculated. This is nothing but what? V0 1 divided by Vi only, right? Therefore, this is V0 1 divided by Vi. Therefore, tell me what is V0 1 divided by Vi? AV is equal to minus mu into RD divided by capital RD plus small rd plus 1 plus mu into Rs. Right? Now, similarly in the case of C with RE amplifier, tell me what is your voltage gain? Your voltage gain AV is equal to V01 divided by Vi, which is nothing but AI into RL divided by Ri. Right? Maybe if you do, then tell me what is AV? AV is equal to minus HFE into RL. What is RL here? RC divided by HIE plus 1 plus HFE into RE. This is what we got, right? This is what we got. Now, still it is depending on H parameters, therefore it is not stable. That's why I told, right? It is like AF, the voltage gain with feedback is equal to A by 1 plus A beta. I already explained. If A beta is very much greater than 1, then AF is equal to 1 by beta. Similarly, if to make them independent of H parameters, if 1 plus HFE into RE is very much greater than HIE, then I can neglect HIE, then HFE 1 plus HFE is approximately equal to HFE, HFE 1 plus HFE will be cancelled, then what is your voltage gain? We got approximately minus RC divided by RE. This is derived formula, okay, and this is original formula, but typically the derived formula is valid. Typically, therefore I am keeping in box. Both are true. Similarly, this is what your voltage gain, but still it is depending on what? Mu. Mu is depending on Gm. Therefore, it is depending on Gm. Gm is depending on temperature. Therefore, it is not stable. Like A by 1 plus A beta. To make it open loop gain, to make it independent of Gm, if 1 plus mu into, same as that, Rs is very much greater than capital RD plus small rd. At least 10 times. Okay? Then can I neglect capital RD plus small rd? Yes. If I neglect it, mu by 1 plus mu will be in the order of 30. Then mu by 1 plus mu will be cancelled. Then your voltage gain will be approximately minus RD divided by Rs. Remember, now this is stable, but value is low. Here also this is stable, but it is also low. The gain is low. Because if you want stability, lose gain. Same thing. If you want stability, lose gain. Tell me, in the derived formula, that is nothing but what? Ratio of RC to RE, ratio of RD to RS. What is the difference? It is independent of transistor, right? Whether it is BJT or JFET or MOSFET, that will not change. Because feedback is the one which is what is controlling. Because your closed loop gain is depending on beta network, passive network, not active network. That's why 1 by beta, it's not A by 1 plus A beta. If A beta is very much greater than 1, it is 1 by beta. It is depending on passive network. Therefore, depending on passive network. Okay? The feedback is dominating. To say that it is dominating, this condition should be true. Only when this condition is true, then only that is what is depending on beta network. Okay? Take it. Whatever observation we got in the case of BJT, similar observation we are getting in the MOSFET. We are not seeing anything extra, right? Okay. Now write down third one, CD amplifier. In the case of BJT, CC amplifier. In the case of MOSFET, CD amplifier. Third one, CD. Drain means what? Collection. Therefore, CC amplifier. This is drain, source, gate. Therefore, what is this circuit in the case of BJT? This is nothing but CC amplifier. Collector, source, gate. Sorry. Writing MOSFET terminal, emitter, base. Okay. Now, why it is CC amplifier? We are applying input voltage at base with respect to ground, taking output voltage at emitter with respect to ground. For AC analysis, your VCC is connected to ground. Collector is at ground. Therefore, for both input and output, collector is at AC ground or ground. Therefore, common collector amplifier. Similarly, applying input voltage at gate with respect to ground, taking output voltage at source with respect to ground. Drain is at AC ground. For both input and output, drain is common. Therefore, common drain amplifier. Now, don't write, listen. Here, what is voltage gain? Voltage gain AV is equal to V0 divided by Vi. This is nothing but what? V02 divided by Vi. We already calculated, right? This is nothing but V02 divided by Vi when RD is equal to 0. When RD is equal to 0. If this is what is the case, what is AV? AV is equal to, what is V02 divided by Vi? Mu into RS divided by capital RD plus small rd plus 1 plus mu into RS. But now we need to take RD is equal to 0. When you take RD is equal to 0, mu into RS divided by small rd plus 1 plus mu into RS. This is what is your voltage gain. Right? This is your voltage gain. Now let's see what is voltage gain of CC amplifier. What is voltage gain of CC amplifier? AV is equal to V0 divided by Vi. Then we got, what is AV? AV is equal to 1 minus HIE divided by RI. This is what we got. AV is equal to 1 minus HIE divided by RI. That time I told, if this is true, if RI is very much greater than HIE, if the input impedance, yes, that is true, if input impedance is very much greater than HIE, then what is your voltage gain? Your voltage gain is approximately equal to unity. This is the original formula, but this is derived formula. This is what is derived formula. Now coming to, if again similar condition, 1 plus mu into RS is very much greater than small rd. Typically this is true. Then can I neglect small rd? Then mu 1 plus mu will be almost cancelled. RS will be almost cancelled. Then your AV is approximately equal to 1. But remember, here you may get, example, you may get it is in the order of 0.98, 0.985, but this is in the order of 0.91, 0.92, 0.93, but close to 1. Less than 1, but close to 1. Okay, this is almost unity. That is the difference. Okay, take it. So for CC amplifier voltage gain 1, CD amplifier voltage gain 1. There is no change. Okay. Almost the session is over. Then let's continue in the next session to see the output impedances. Okay. Whatever we had seen till now, right? Common source amplifier, CS with RS amplifier, CD amplifier, CD with RD amplifier. For all 4 configurations, we need to find output impedances. But instead of finding again individually, let's calculate for CS with RS and CD with RD, then take other 2 conditions. You will get, means RS 0, RD 0, then you will get for other 2 remaining derived configurations. Okay. Let me stop now. If this is over, fine. I think you can play it for 1 more minute or 2 more minutes. It will be continued. Then in the next session, we will see the output impedances. Okay. Thank you.